Okay, today we're going to be looking at section 10.3, which is operations with radical expressions. Hopefully by the end of this section you can say that I can simplify sums, differences, and products of radical expressions. Okay, so what are we going to be doing today? Well, first of all, we're going to be able to take the sum and a difference of a radical expression. So for instance, on this first one, if we got 11 root 7 minus 4 root 7, we simply subtract the coefficients out front. Very similar to if I had 11x minus 4x, I would get a 7x. So here I'm going to get a 7 root 7. Okay, this next one here, 5 root 5 plus a root 5, that's just going to be a 5 plus a 1, which would be a 6 root 5. Okay, hopefully this is making sense so far. Okay, so for instance, if I have this one, I have 9 root 10 minus 8 root 10. Hopefully we can see that that's going to be 1 root 10, or just a root 10. So this next one we get to 8 root 2 minus root 98. At first when we look at it, we say, oh, they're not even like terms. However, 8 root 2 stays, but we just need to simplify root 98. So the biggest perfect square that goes in there is 49, and it goes in there 2 times. So it's really 8 root 2 minus 7 root 2, which gives us just 1 root 2 or 8 root 2. Okay. Next one, same idea. We look for the largest perfect square that goes into 245. So if we looked at 49, 245 divided by 49, we're going to get that 5 times. So this would be root 49 times root 5. So that's 7 root 5. And then if you take 320 divided by 5, you're going to get a 64. So this is really 2 times root 64 root 5. So what do I get? I got 2 times an 8 root 5. So that's 16 root 5. So we have a 7 root 5 plus 16 root 5, which would be a 23 root 5 in the end, would be your final answer. Okay, same idea over here. If we look at 54, we know that 9 goes into there, so that's 2 root 9 root 6. But root 9 is really 3, so it's 2 times a 3. So you got 6 root 6. In 96, 16 goes into there, so that's 3 root 16 root 6, but 16 is really, root 16 is really a 4. So I got 3 times a 4, which would be a 12 root 6. So then I have a negative 6 root 6 in the end. Okay. How about these now? If we're doing a product, which simply means we're going to multiply. So we're going to still use a distributive property here, just like we would before. So if we distribute, we'd have a root 15 plus root 9, but that would simplify to root 15 plus a 3. Okay. This next one, we got a negative root 8 times 2 and minus 3 root 6. So first thing I would suggest doing is if you can simplify something, simplify it to start. So we got a root 8, which is really root 4 root 2, so it's really 2 root 2, or a negative 2 root 2, times 2 minus 3 root 6. So when I distribute, I would get a negative 4 root 2 plus 6 root 12. So now, how do I deal with that? Well, I know that root 12 has still got a perfect square in it, which is 4. So that's 6 root 4 root 3. Root 4 is really 2, so it's 6 times 2, which is 12. So it's negative 4 root 2 plus 12 root 3. Now I can't go any farther because the root 3 and root 2 are different or not like terms, so I would stop right there. Okay, how about these next ones? So if I distribute here, 2 root 10 times a root 5 would be 2 root 50. And if I distribute on the second one, I'd get an 8 root 100. Well, root 100 is really 10. So it's really 8 times 10, which would be 80. And then root 50, there is a perfect square in that, which should be 25 2 times. So that's really a 5. So 2 times a 5 is 10 root 2 minus 80 then. It would be your final answer. Okay. The next one, we got 3 root 3 minus 2 root 2 squared. So what does that mean? Well, that really means 3 root 3 minus 2 root 2 times itself. So I prefer to just write it out like this, and then we're going to either use the box method or the FOIL method. I'll first show the FOIL method, or distributing, however you want to look at it. So I got 3 root 3 times 3 root 3, which should be a 9 root 9, but that's really a 3, so it's really 27. Okay, and then I got a 3 root 3 times 2 root 2, which should be a negative 6 root 6. Okay, and then I come to the inside term, which would be a negative 6 root 6 again. And then this one would be a positive 4 root 4, but root 4 is really 2, so it's really plus 8. So if I combine my like terms, my final answer would be a 35 minus 12 root 6. Okay, now I could use the box method for that as well. So if you like to organize it with the box, this would be a 3 root 3 minus 2 root 2. This would be 3 root 3 and a negative 2 root 2. And then you just simply fill in your boxes. So we said that this would be a 9 root 9. This would be a negative 6 root 6. This would be another negative 6 root 6. And this would be a positive 4 root 4. And again, these would simplify. This would simplify to 8. This would simplify to 27. If you combine your like terms, we end up with the same exact answer. Okay, so again, it's just kind of personal preference on how you want to work with them. Okay, these two would be the same way. So if we want to FOIL, or if we want to make the box, your choice. So if I do the FOIL method, first times first, we get root 9, which is just 3. We'd get a negative root 18. We'd get a positive root 18. And we'd get a negative root 36, which is really minus 6. These two cancel, so I really end up with a negative 3 in the end. Okay, if I look at this next one, if I do the FOIL again, or maybe let's try the box on this one. Okay, so I got a 2 root 2, a root 5, I got a 2 root 2, and a negative root 5. So this would be a 4 root 4, which is really 4 times 2, which is 8. I've got a 2 root 10. I've got a negative 2 root 10. And then this one would be a negative root 25, which is really a negative 5. These cancel, so I got 8 minus a 5, which is a 3. Okay, so hopefully that's making sense to you. We're just kind of combining some of the things we've learned this year with simplifying radicals and the FOIL pattern of the box method, and just applying those to different situations. Okay, and that is a wrap.